All right, hey guys, so this notes is going to be page 12, and our title is going to be proportional versus non-proportional. So I want to know, how can I tell if a graph, equation, and a table are proportional? Now this is going to be another one of our easier lessons that we do this year. So when we're talking about proportional, there are two main things that we need to know. And it has to have both of these qualities in order to be proportional. So the first thing we have to have, it needs to be a straight line. That is important. So it needs to have a constant rate of change, and it needs to be a straight line. Our fancy term that we're going to use is linear. And just as an easy way to remember what linear means, it literally has the word line in it. So that's the first thing we need. We need it to be a straight line. And number two, we need it to go through the origin. And what that means is the straight line is going to pass through the point 0, 0, right? Or the center of the graph. The other thing it means is that my y-intercept, or my b, has to equal 0. Okay, because if it's going through the origin, that means it's crossing over the y-axis at 0. So my y-intercept is 0. It's going through the origin, and it's a straight line, which means it's linear. Then we have a proportion. If it does not meet both of these qualities, so if it's a straight line that does not go through the origin, it is not proportional. And if it's something that goes through the origin but is not a straight line, it is not proportional. It's either both, or it's all or nothing. So it's either both or it's not non-proportional. So we're going to do this. If you guys notice, this is basically the same set of notes as our previous page, because these examples apply to both the y-intercept and if something is proportional or non-proportional. So in this case, our first one, we're going to have y equals mx plus b, right? So here, we're going to box our variable just like we always are going to do. And here we have our b, or our y-intercept. So the only way this is going to be proportional is if b is equal to 0, or it's not there. So here are my examples over here. So right now, I have 12 equals 4x plus 2. I look outside the box at my y-intercept. It's a positive 2, not 0. So this first one right here is not proportional. Now my second one, we're going to do the same thing. So we're going to box our variable. Now notice here, I don't have anything outside the box. So like we said in yesterday's lesson, that means my y-intercept is 0. And if my y-intercept is 0 and I have a linear equation, which we'll go more into next week, then this is going to be proportional, right? So this is, yes, this is proportional. Now, if I come down here and look at the graphing, so it needs to be, the graph is honestly the easiest one to tell if something is proportional, because we're looking, is it a straight line? So is it linear? And does it pass through the origin of 0, 0? So I look at this first one. That is a straight line, and it goes through the center. This one right here is proportional. So I'm going to write a P right next to it. The second one, it is linear, right? It's that straight line, but that y-intercept does not pass through the origin. We need it going exactly through the middle, and it does not. So this one right here would be a non-proportional linear equation. And then the last one over here, my y-intercept is up here. Remember, y-intercept is where do you cross the y-axis. Yes, this is linear. It's a straight line, but it does not go through the origin, right? It does not go through the center. My y-intercept is not 0, so it's another non-proportional relationship. Now for a table, you are mainly going to check for two things. So this is going to be the hardest one. So the first thing you have to check for, and this is the easiest one, you have to check to see you need the point 0, 0, right? We already said that if it's going through the origin, that means it's 0, 0. So if your table does not have the point 0, 0, it is not proportional. So for example, this one right here, I have 0, 5. It's not proportional. Now, to test to see if it's a straight line, what you have to do is you have to see if there is a constant rate of change. So by that, I call these butt cheeks. So every time it's increasing by 5, over here, every time it's increasing by 1, it's doing the same thing every time. So my constant rate of change is 5 over 1. So this one would be linear, but we already said it does not go through the origin, so this one is non-proportional. Same thing over here. I'm going to check. I'm going to find my y-intercept. It is at positive 8. So here I can write, positive 9. So I'm going to write b equals 9 because that's my y-intercept. My y-intercept is not 0, which I need. So this one is going to be non-proportional. If just to double check, I wanted to see what my constant rate of change is to see if it was linear. Every time we're increasing by 3, every time we're increasing by 1. So this would be linear, but it is not proportional because it is a straight line, but does not go through the origin. And if you remember from yesterday's lesson, so we have to continue our table up here. My next one would be 0. If we continue the table up, we get 4. 0, 4 is not proportional because it is not going through the origin of 0, 0. However, this is another case where it is going to be linear, right? Because plus 3 plus 3 plus 3 plus 1 plus 1 plus 1. But it has to be both linear and go through the origin in order for it to be proportional.